How's everybody doing? Good? Happy Monday? Happy long weekend? We're all here without water. For those of you who don't know, the water is not working until noon. They say 11, but I'm going to assume noon. So what we'll maybe do is take a break at around 11, and then I'll quickly use that break to check on the water as well, which hopefully will be back on, but it's up to the construction folks. They just said after 11, whatever that means. Yeah, so welcome to week 3, day 1. How was yesterday and day before in terms of the weekend homework? Hopefully people got through it. I saw completions for most of you, not all of you. So I'll assume that you're at least, most of you are somewhat read up on the stuff that you'll be doing this week. And kind of, as you know, the weekend prepares you for the week, right? So hopefully you're coming in feeling okay about some of the stuff that you read on the weekend. And of course, we will talk about HTTP this morning, right? So that'll help you with today's lecture. If you haven't gone through the weekend stuff, it's not like the lecture will be completely like this for you. It'll just, the stuff on the weekend will help you with, if you're not done it, definitely do it before you start today's stuff, right? Because it's a dependency for today's stuff, essentially. So this is the agenda that I have. We're going to first talk a little bit about TCP because we used it last week, right? And then we're going to get into HTTP, which is a major part of today and this week. We're going to kind of build some HTTP servers first with just Node and then with Express. And we're going to go deeper into Express than what was covered on the weekend. So on the weekend, there was like a very short Express tutorial that just gets you to get some routes set up. But we're going to go deeper with Express. For example, we're going to talk about EJS. And hopefully, we'll get to talk about middleware too today. And if not today, then we'll talk about it later this week. Did you need some time to get set up there, Renee? You're good? OK. So TCP review. What is TCP? Of course, there's the thing that it stands for, but I want like a deeper technical explanation. Who wants to volunteer and answer? What is TCP? I'll wait. It's a holiday, right? I can wait longer. Sure. So there's a handshake process, somewhat technical in terms of what's the handshake process for. Okay, but what's the goal of TCP? Like, start with the overarching kind of, what does it solve? What does it do? What does it enable? Yeah, Peter? To transfer data between server and client, yes. Secure, I guess it depends on what you mean by secure. Again, it depends on what you mean by secure. If you're meaning the traditional definition of secure, where like people can't look at the data and you can feel safe about what you're transmitting, then no, TCP does not provide any level of encryption or anything like that. You'd have to add that on yourself. But the majority of, but if you meant secure as in like, you can trust that when you send something, you'll know if it's made it or not. You'll get like a confirmation, essentially, right? So you can. It's whereas the alternative, UDP, you don't actually know if the data that you sent actually was received or not, right? So I'm just going to close this door over here. Oh, thanks. Oh. Yeah, so TCP essentially allows a computer. Is that what a computer looks like? Allows a computer to establish a long-running connection. Think of it like a telephone call with another computer or device. How did we use TCP last week? With the net module. So we use the net module here to establish a connection with a server, right? So we were the client. And we established a connection with the server, right? Something like that. And then what did we do once we established the connection? Yeah, we sent commands, I guess, as like sort of string data. So we decided that the communication between the client and server was going to be using English and using string or text. It doesn't have to be that way. We could have decided on any kind of language. We could have decided on non-text and just sent like weird kind of characters that would show as garbage on the screen. But we decided kind of visible text and English letters so that we could recognize also, and it'd be easier to debug and understand what was going on, right? So what was some of the commands that we sent up? Remind me. Wasn't it something like move? Yeah. So like it would send up like a move colon up, something like that, to the Snake server. And will the server send anything back? Once you decided to send move up? Do you remember? Nobody remembers? I don't think it did. I don't think it sent back some text saying, you've moved up by 1. Did it say something like that on your screen? No, right? When did it actually send commands? So I guess this is going this way. And then there'll be other commands like that, right? When did it send text this way? Yeah, so it could be like it could be like a string like you dead or something like that. I forget the exact text that it sends back. Or if there was a timeout or something, right? If you idled for a little bit, it kicked you out, it booted you. And so it sends strings back, and then we could send strings up. And how long could we do this for with one connection, with one snake instance? Just showing the snake on here. There's like little things going on, right? Yeah, for how long could you do this for? As long as you don't die. So it could be a minute, it could be a day. There's no kind of restriction that's saying that you have to have a TCP connection end after a certain kind of period. Right? So that's an important attribute about TCP, is that it is a long-running connection. Right? It's a long-running connection between client and server. And in our case, the client initiated the request to start up this instance of a snake. Is that kind of always the case with TCP? Or can the server initiate a request with its clients? Is that possible? So we have something like a snake server running. It could be some other type of game. Can it connect to clients to start up a new game or new player? Take a guess if you're not sure. Logically, does that make sense to you? No, right? It doesn't know who the clients, where they are, what their IP address is. Somebody has to actually start the conversation, and then it's able to send messages back and forth with that initial connection. So connections are always started by the client. Connections can last as little as a few milliseconds, like basically a really quick conversation. Hey, hello, what's up? Done, right? Or last a really long time. What are some ways that the connection can end? Connections can end by some sort of timeout. But what would be a timeout? Like, who decides on what the timeout is? Okay, so server basically decides after x time. So it could be a server decision to terminate. Yeah, client. I think we used Control-C and then we ended the connection gracefully by using connection.end or something like that, if I recall. Yeah, but I think, okay. Yeah, Control-C, but I thought we had on quit, it would send a connection. I can't remember. But either way, Control-C is like an abrupt end, and then there could be like a more kind of graceful, using the net library to end the connection. So client decision to terminate. Any others? What else could cause a termination of essentially the proverbial phone call between two machines? Network disruption, exactly. Network disruption of some sort, somewhere, or anywhere between the two connections. It could be our local Wi-Fi goes down, or our entire internet goes down, or on the server side, that's what happens, or something in the middle goes down, right? Also, forgot to mention, do the computers need to be on the same network? For example, Wi-Fi or local area network, for TCP to actually work. In our case, that was true, right? The Raspberry Pi was running right there on the same Wi-Fi local area network. Is that the case all the time? Or are we able to establish TCP connections if the Raspberry Pi was instead running somewhere else in the cloud? Would that have worked? Is that possible even with TCP? Yes, absolutely. Right? So as long as, same rules apply, as long as they know how to talk to each other. So TCP is essentially a protocol that allows, it's transport control protocol, right? But it basically allows data to be sent back and forth. And the most important property is, which we forgot to actually write down here, is that both sides can send data to each other of any kind, anytime. So it's not like, hey, I'm speaking, and then it's my turn, and then it's my turn, right? We could have sent 10 move-ups, right? And then maybe by the 8th one, it's like, you dead, right? And so it just kind of ignored the last two move-ups or something like that. There's no kind of, there's not like a, with a phone call with two people, it's kind of weird if two people are talking at the same time. Would you agree? But is it possible on a phone call to do that? Yes. So you can picture that TCP is kind of the phone connection, but not necessarily the two people talking. Right? It's kind of like that thing that actually enables you to talk to each other, and then you can decide how long that conversation is. But then it's up to the people to decide how they want to talk to each other. Should they talk over each other or not? In the case of the Snake server, it was totally okay. Are we comfortable with that as a review? Was that useful? Any questions about that? And take my awkward pause. No. Yeah, sure. Anthony, right?
Yeah.
Yeah.
So, just out of curiosity, I used to, before as a kid, I used to make Minecraft servers.
Nice.
And then, I would have to port forward. I'd have to learn how to port forward off my own router. And I was just curious, I think we were talking about earlier how ports work. It's just
Yeah.
And then what happens if, so let's say if the Raspberry Pi server was located somewhere else, and would we have to find out which ports are open? Because I know not all ports are open automatically.
Yeah, so the question from Anthony is about port forwarding, like he's had to do that in the past. So the answer to that, I'll keep it short because I don't want to digress too much, and it's something that you should look into in terms of if you're interested in fully understanding networking, or even something that you're interested in getting more into. If the Raspberry Pi needed to be connected to from the outside, but we still wanted to have the device here, but then allow you to work from home or something and allow you to connect to it, you wouldn't be able to that day, for example, if you weren't in, because we haven't actually allowed it to, this particular machine, to actually be able to listen on our public IP address, just on our local IP address. It has a local IP address when you connect to it, right? And so in order to actually allow it to be accessed by a wide area network, by the internet, or any device on the internet, we'd have to open up a port on our actual router, which is what has the public IP address. So there's one public IP address that we all share because we're on the same router essentially. And so that router is the one that would get the connection from an outside, right, on whatever port they decide. And then it would be like, I don't have anything running on that port. But we could go into the router's configuration and say, actually, anytime anything comes into port 8005 or whatever, don't just try to forward it to this other IP address internally so that it can be handled. So this is our router in the case of the internet. Here, server. And then it would, or rather the router would be like here. And it's the one with the public IP address, and then it would forward to the server, right? That's if you want to have something running public in your home, for example. If you're running any kind of server, and you want outside access, you would have to port forward from your router. It's a good question. Any others? Now, there's two protocols at play here. There's the transport control protocol, which is, again, the phone call, and the infrastructure to be actually able to have a long-running communication channel, right? And then there's the protocol of what the two pieces of software actually talk, how they actually talk, right? Like the server, if you sent it something like sit : down, what would it say? It actually does respond back. I forget what the exact string is, but it's something like, I don't understand. Something like unknown command. It doesn't know what's going on. So it's like there's the actual phone call protocol, and then there's the two people, what they actually speak. What language are they speaking? What commands do they actually accept? So there's that protocol as well between the two. So the word protocol is used quite often when it comes to people or devices speaking, right? And there's different layers of it. So we're going to talk about HTTP. Now, I say review here because there was a little bit of stuff on the weekend for it. So does anybody want to kind of start that off? What is HTTP? I'll start off with what it stands for. Something like that, right? Hypertext Transport Protocol. What does it actually do? What does it allow? How does it work? Start with any of those questions or answers. What is HTTP? Anybody want to start it off? Yeah, Peter again. allows text UTF-based communication between computers. Well, this sounds like TCP, right? I mean, TCP allows text-based communication between two devices. So I think we need to be a little bit more specific. It's accurate, but it's too vague still, such that it's defining the underlying technology that it's using, which, by the way, HTTP, another property of it is that it uses TCP to do the below, right? Anybody want to go a little bit further? Yeah, Max? Right, a client makes a connection, makes a request, server makes a response. Still sounds a little bit like this, because the client has to make the connection, because it's using TCP. But you are onto something, even though you're kind of still being vague, in that it is request-response-based protocol, where unlike here, where it's long-running and we can just keep controlling that snake through commands and decide to send a whole bunch all together and not really care about the response, about our move commands, HTTP says, no, no, no. When the client connects, it's going to send up a string, much like this, but the command will be about, it'll be a request, right? So there'll be a step one request, and then there will be a response. So underlyingly, it's still using the same infrastructure. It's using TCP, right? So this is still TCP. That it's using to connect. But no longer is it a game client or a game server, right? It's called a HTTP client instead of a snake client and an HTTP server, right? And that means that the language that they speak is no longer move : up. It's something like get / I want to get the home page, please. Or get / about. I want to get the about page, please. Right? And so that's going to go in this direction. Right? And then it waits. And it may take a second or two for this thing to figure out how to respond with the HTML for that page, at which point it then sends back. What does it send back, actually? Sends back a response in terms of what we define, what we call it. But what does that response contain? Or at least, it contains many things, but what are some of the things that it contains? Headers, yeah. Which headers are the most important? The one that like kind of aren't optional. Remember your name again? Oh, Anthony. You guys are both Anthony. And you are? Maggie. Okay. So you said, Maggie said headers, and then what? Status code. Yes, exactly. So it will send back a status code. Something like, 200. And then it will send back some data, right? Here's the data for the about page. So it'll be like and a bunch of other headers as well. And then there will be kind of some, HTML. That comes back. What happens after that second step is very different than what happens with the snake server. Because the snake server, it's like, OK, let's keep going, right? Let's keep the snake alive as long as possible. Here, it's like, OK, I have the data. And essentially, depends on the version of HTTP. It will, at that point, decide to end the connection. So this is kind of the, we'll just mark it like an X. The client decides to terminate the connection, especially with like old versions of HTTP. Now for performance reasons, this kind of sucks because the client, the browser, needs to request many different files, not just the HTML page, but there's CSS, there's JavaScript to run in the browser, there's images, potentially a video, music, who knows. So there's all these assets that are needing to be downloaded that aren't just the HTML. They're going to be referenced in the HTML, using tags. And so these image tags and stuff will still need to be downloaded to render on the page. And so oftentimes it doesn't kill the connection, but essentially it starts another request, right? So it's request, response, request, response. For each request, there must be a response. Otherwise, it's sitting there waiting. It can't, let's say it couldn't get the CSS. It's just waiting. The server maybe is hung up on something, and it can't draw the page properly, right? So it's a very request-response based. But what's nice is hypertext. It's text-based. So we're actually able to see what kind of stuff goes back and forth in terms of the communication between the client and the server. Pretty cool, right? So request-response-based protocol. And the missing piece here that I kind of hinted at is that it's based on being able to fetch or submit new resources or documents, essentially, is the way you could think about it. Because when the web was invented, it was very much thought of as like documents, like text documents, right? It was not, there was no visual, there was no like kind of drawing of things. And so it was very much text-based documents. And then they said, well, we want to be able to have some markup. And so that's why it's called hypertext, because it's got some markup in there. The text actually means something. Any questions about this so far?
Yes, so could we say that the HTTP is like the structure of how you send a request or how you get a response or not?
Yeah, that's a good question. So what is HTTP in relation to TCP? Is that your question, essentially, in different words? Yes. Camilla, right?
Yes.
So Camilla's asking, kind of like, in summary, would you say HTTP is like the, you said instructor? I would say it's, unfortunately the term is it's still a protocol, right? But it's kind of like the rules of how to speak to each other. Like for example, I could have a snake server running and then decide that I'm going to make a HTTP client connection, and it will say get, and the server will say what? Unknown command, because it's expecting move : whereas this decided to send get. So it's kind of like the language. Just like the snake server had one, but we didn't call it HTTP because we just came up with a snake protocol, right? Remember how I said there's two protocols at play? There's the TCP protocol, which is the phone call connection, and then there's how the two people know to talk to each other. Snake client, snake server, they're going to work well together as long as they're programmed properly, right? Snake server, HTTP client, they're not going to know how to talk to each other because one speaks HTTP, the other speaks snake. They're kind of alien to each other. And vice versa is true as well. So really, they need to be speaking the same language, just like with humans, in order to actually be able to communicate. And those languages have rules, right? In this case, the rules also mean request response versus talking over each other. Because every single command is not just about moving a snake, it's actually about requesting something to be changed or fetched from the server, like creating a document or retrieving a document. And so we need a response to know what happened and what is the result. What's the actual HTML that resulted from us fetching that document. So that's why it needs to be request response based, right? Another way that I like to describe it is that because we say request response based, I like to say that it's transactional. I make a phone call, I say, can I have this please, and then I hang up, right? Once they actually respond, I hang up. So it's a very transactional kind of relationship between the client and server. They don't actually have a long-running phone conversation about various things. It's mostly just like, can I have this please? Oh, can you save this please? And then it's kind of done, right? So let's take a look at what that looks like in terms of implementation. This is a little bit of a review, but not necessarily a bad one. So we will open up the HTTP server here. And right now it's incomplete. Yep. So the question is, can HTTP talk over each other or not? It's a little bit of a loaded question because it depends on the version of HTTP. For example, like it could send, like in the later example, like later versions of HTTP, which are not yet fully adopted, it could make multiple requests and then start getting the responses. So it's a little bit more performant, like HTTP 2 and 3 are faster as a result. Whereas HTTP 1.1, I believe it's very much request, response, request, response, request, response. So for a given connection, it's not going to make multiple requests, but I'm not 100% sure. Yeah. Is there a question in the back? I saw a hand thing. No? So if we look at Node's HTTP module, right? Just like Net, HTTP is built in to Node. You don't have to install an npm package for HTTP to work. And we can use it to create a server. Right? So if we look up HTTP create server, and I should type in Node ideally, then W3 Schools gives you an example, and it looks something like this. So it gives you, what the example they give is, you say, the module that you require, and we know that when we require something, what do we get back? We get back an object usually, right? And so in this case, the object has a method called createServer. And so we're going to call createServer on it, and then we'll go from there. So let me actually go ahead and do that. And then we would do server.listen. Actually, let's go ahead and just console log server. Like, let's take this one step at a time, right? What the heck is this? In fact, let's even just console log HTTP. This is how I'd expect you would be getting introduced to something. Even if the tutorial is going 3 steps ahead, you should kind of be saying, well, what is this thing actually, what is the value of this? What does it look like? Just so I'm getting comfortable. Maybe I'll never see it in that way, but I'd like to see kind of, what does that look like? Especially as we're new to code, not just new to HTTP. It'd be a good idea to do something like this. So let's go ahead and run this. So it looks like it's an object, and it has kind of some properties which we're not going to use directly, especially because they start with underscore, which kind of implies that they're not meant to be used. They're kind of internal state management, like it's just its own kind of data. Looks like a whole bunch of numbers. They look like HTTP status codes, eh? Like, apparently 404, right? We know 404, not found, right? And by the way, these status codes, there's a really cool site, HTTP status codes, cats, I think. Yeah, there it is. Cats make a reappearance in this course. They never go away. They never quite go away. And there's a cat for each HTTP status code. Like 100, continue. Or accepted. Created is pretty vicious. Like, whoa. It's pretty angry about the fact that something was created. I like no content. It's hard to pick up what. I hadn't seen that one before. Method not allowed is great. Not found. So good. Conflict. I'm just going to take some time to kind of like take all these in because it's been a while since I've Oh, and you might have noticed this in the output. I'm a teapot. So that's the thing. HTTP has a actual status code, which is 418. I'm a teapot. It's a thing on MDN. The client error response code indicates that the server refuses to brew coffee because it is a teapot. This error is in reference to hypertext coffee pot protocol, control protocol, which was an April Fool's joke in '98. They decided to put it as part of HTTP. It was like a RFC, essentially, a request for change to change the protocol right here. RFC 2324, section 232, 418, I'm a teapot. Let's open that up. Right there, there's a whole document in traditional kind of RFC format saying we're going to support these brew methods. Yeah. They kind of talk about it. 418, I'm a teapot. Any attempt to brew coffee with a teapot should result in the error code, I'm a teapot. The resulting entity body may be short and stout. Yeah, I guess we like to have a front a little bit too as well. And I think there's like a nice hypertext coffee pot protocol Wikipedia page that describes it. And essentially the idea is if you were to have a teapot running an HTTP server, right? Then if you try to send a request to it, it's like, hey, I'm a teapot. I can't brew coffee. Yeah, it's a thing. Anyway, I digress. So this object kind of gives us some insight into what's available. And it looks like there's a method on there called createServer. And we're going to use that. So http.createServer. Okay, so that gives us back another thing, as we know from documentation. And we can then go ahead and console log that. So now I expect, we can get rid of this console log for now. Whoops. So here, we see that we have another object of type server. And it has some interesting stuff, right? But a lot of kind of private stuff here as well. And then some additional information. We're not going to necessarily find a lot of value here, but what we get to learn is that we get back an object. We don't get back like undefined or something of that nature. Now, when I run this, why does it keep doing that? When I run this, it doesn't like keep running. It like ends the program. But from what I understand, a server should just keep running, right? It's waiting for connections. So that only happens when we call server.listen, and then we say which port we would like to listen on, right? So let's say I did something like 3005. And then there would be a callback to let me know that it's able to actually successfully listen. So we would just say console log server is listening on port 3005. Something like that, just so that the person who launches a server gets to see that it's running, right? That this callback was called. Any idea why this would be a callback? And why I wouldn't just put this console log out here? Why do we do things as callbacks in Node? That might be a hint to help you answer that question. Why can't we just call listen and then do the console log on the next line? Yep. Yes, so that's correct. Here it's going to be misleading because it will run, let's call this after listen. It will run right away after listen, and then this will run thereafter. But I guess why I'm asking is, why does this work that way? Why do we use a callback here? Why didn't they make it so I could just run it right after? The same is true for like something like read file on FS, right? Why do I have to provide a callback when I'm reading a file? This allows, so I guess what I'll define is a little bit of what listen does. Listen actually binds to that port to say, okay, now I'm accepting connections. Okay, so once listen successfully completes, which is right here at line 10 that we know that it's successfully completed, then we know that it's listening for connections and clients can start connecting. So why does it need a callback for us to know that it's ready and listening for connections? Yeah, it's a request that does take some time, just like reading a file. It's not going to be the same as reading a 2 GB file or something from somewhere, but it is going to take a few milliseconds. And so Node doesn't like to be blocking and waiting. And so anything that is a little bit going to wait for a system call, and it tells the operating system that I need to use this port, please. Hopefully it's available. You know, the operating system takes time to like get that going and wire that up. So that takes some time. And so we then therefore need to use a callback to deal with things that take time, right? So let's go ahead and run it. And now we'll notice that, you know, there it is, right? It's the very last thing that's printed out, since that takes some time. And now there's no, it's not like doing anything. It's kind of just stuck, seemingly. And that's because it's in essentially a loop waiting for connections, right? So I'm able to now connect to it, you know, using my browser. Now, if I try to connect to it using my browser, because I've run it on port 3005, I'm actually going to connect to. So if I do, let me start up a new thing here. HTTP localhost 3005, right? There's something there, like it's like, oh, I guess there is a server there, otherwise it would complain. Like for example, if I tried 3006, it would just be like, there's nothing at 3006, right? It just can't be reached. Something's wrong, connection refused, right? But 3005, it's like kind of spinning, waiting. Now the problem is that I haven't defined what to do when a connection comes in, so it just doesn't know how to handle connections. So that's the next step. So we're going to kill the server, which will kill the, notice how the browser also stopped spinning? And it's like, it didn't send me any data, empty response. You know, it was able to make a connection, but it didn't get back a response. And the initial request that it was trying to make was for the home page. And it didn't get back a response. In fact, we could have seen that in the dev tools that you guys played around with a little bit already. But I would have to refresh. So never mind that. Here, I'll just clear it. So let's go ahead and specify a way to actually handle incoming requests. And the way to do that is by providing a callback function. Let's call that callback function request handler. Okay. If I run this right now as a Node app, what do you expect will happen? There should be an error, right? What will the error be? It doesn't know what the heck this is. Not defined. I'm going to go ahead and define that. Now I could have just passed in the function directly, but I decided to give it a name. And this is a function that will be given a request response object as 2 parameters. So we can just go ahead and keep it simple for now and just say response.end hello. And before doing that, we'll do a console log to say new request. Something like that. Okay? And then we're going to also respond back with a hello. In fact, you know what? Let's not do that. Let's just do the new request. See what happens. Oh, I'm going to get rid of that long console log that we have, which is right here. So we have server listening on port 3005, local 3005. I hit refresh. Still spinning. Damn it. And I do see, though, as a change, new request. So it's actually, we know that it's going into this function, but we know that it's not sending anything back, at which point we can see in the network tab that there is a get method, which is pending. It's still going, right? We don't even know how long it's taken because it's still pending. So if we click into it, we see that there was request headers that were sent up, like, hey, this is a such and such browser, right? And more specifically, which URL was requested, right? But we don't really know. It's still going, right? So if I go ahead and cancel the server, we see that it came back. Well, unfortunately, it renders this like page, so it kind of loses that get. I should have done preserve log here, so that would have caught that. Let's try it again. Start the server, hit refresh. There it is, pending. Kill the server, and there's our request. It failed, right? It didn't get back. So it sent this, and then the next thing was the server decided to terminate the connection. So it never got back the response. And we can do something simple like, hey, I would just like to end with these final words, which is hello, right? Like, keep it simple, and it sends back some text because HTTP allows text-based transmission of data. So now when I hit refresh, I'm going to clear this. We see that there's a request made for localhost. It's a GET request, came back with a 200 OK. So second step included a 200. And we can kind of see a preview of what was sent back. Let's take a look at the headers, response headers. These were the headers that were sent back. So they're literally text. Like if I view source on this, it's 4 lines. It actually excluded the first line because it's like, that's pretty like common everywhere. So Chrome just tries to be nice. But if we look at the actual text that came back, this is what came back. And we look at the actual source of what was sent up. This is what was sent up. So this was step 1, get /, and then it includes the protocol number. This is protocol HTTP 1.1. We're now at 2, but most things are still using 1.1, unfortunately. And we're actually talking about 3, actually, with HTTP. So the internet's a little bit behind in terms of catching up, in terms of version numbers. And then it kind of says, I'm expecting you to be localhost 3005, and a bunch of like things that are kind of optional. And then the response includes content length. I got 5 characters for you, HELLO. And by the way, I'm also speaking HTTP 1.1, and this is 200. It's all good, right? So that's the, and we can see every time I refresh, there's a new request. Right. Any questions about this so far? Pretty straightforward, right? So what would be my next step if I'm like learning through experimentation here? Right? As I said earlier, lectures are okay at introducing new topics, but they're better at talking about approach. So what would my approach be as a next step? Being inquisitive, learning HTTP for the first time, following some kind of tutorial or example that looks like this. Maybe it ends here. What do I do beyond this? If I'm kind of trying to still figure out how this stuff is working. Any suggestions? Well, one I think I would do is, I have these 2 things here, and I've kind of gotten acquainted with this .end according to documentation, let's say. But I'd like to take a look at them, right? Same thing. Let's take a look at request. Refresh. Holy moly. That's a big object of type incoming message. So now if I wanted to Google that, at least I have something, right? I have something that I can go look up. I found a keyword that I can like Google. Which is interesting. And then it brings me to the documentation for the Node HTTP server. Or the client, in fact. They both get incoming messages. And I would do the same thing with the response. So restart, refresh, and I've got my server response object. So remember we talked about before we got into the code, HTTP is very transactional, request response. And so what these two objects are doing is they're allowing us to get the details or even modify, in this case with the response, what the response will be. So the HTTP library says, okay, if you want to respond to this request, you can do it however you like. And one of the functions you can use or methods you can use is this .end, right? But what we saw in the example from W3 Schools, which was right, where was it? W3 Schools, HTTP, create server. So theirs was, they gave you a slightly different example, which was to use the write function on the response object, which they decided to just call res for response. Call it whatever we want. So they just do a res.write followed by a res.end. Right? So we could do the same thing. And they even do a write head to write some headers. To say, hey, I want to write back 200 and content type text plain. I'm sending back plain text, not HTML. Right? So we could do the same thing. And in this case, for us, this is response. Right? Restart the server, otherwise it's not gonna. And we can see that it's coming back with hello world, which is good. If I wanted to send back HTML, what would I change here? I would maybe include that this would be an H1 or something like that, a heading 1. And if I try to run it like that, it's not actually rendering like HTML because I'm sending it back as plain text, right? So in my header, I would actually say, this is actually text HTML, HTML text. In which case, when it comes back, the browser knows that it's the same data that came back, but it's like, oh, you said in your header that this was HTML. I'll render it like HTML, make it look like HTML. So it actually interprets that as code versus just text. HTML code. So as you can see, it doesn't take a lot of lines of code to get this going. You can build a website pretty quickly, it seems, right? An HTTP site. For example, we could have a website that, maybe this is the homepage. The problem, though, is that the HTTP create server, this whole library, is fairly limited for building large-scale web applications or websites. It only gives me one callback. How am I supposed to know what page was requested and then be able to handle that page differently, like the about page versus the home page? I just have one callback. So I would have to check the request URL. And I'd have to check the request.method. When I refresh, I see that the URL is / and the method is get. Then there's another request for the favicon, like the little, what the tab shows as the icon. Browsers just do this by default. So it actually makes 2 requests. But we'll ignore this one, because we don't really need to care about it. Really, it's this is the home page that's requested. Right? So if I go to /about, I get the same response back, hello world. But it's like, yeah, that was for /about. Right? So I could do something like /kv, /is, /awesome. Doesn't matter. It's going to be like, you get back the same text, hello world. So, but we at least know how to fetch this information. How would I support different pages now to send back different HTML, knowing that I have this information? What would I do in this callback? In this request handler, I have access to the request object. For each request, it's a different object because it's a new request, but it contains details about that request. The URL and the method are the two most important things because they tell me what the user is trying to do. What are they trying to access? What resource are they trying to get? Right? What could I do here if I wanted to support two different pages and not just always respond with hello world, but in one case respond with maybe home page, and in the other case respond with about page? How would I do that? And then for any other one, I want to say 404. How would I do that? It should be doable now that I have these two pieces of information. Because the URL tells me what they're trying to access, like /about or just slash, right? It's a string. And then the method is always a get in this case right now, but it tells me what they're trying to do, like a get versus a post. An if-else statement, perhaps, yeah. So what if I do something like if request.method is a get and request.url is slash, then that's homepage. Maybe homepage is like this. And then it would have additional content, right? And then we would have an else if, I guess, right? Else if request method is a get and the request URL, instead of a / is / about, then I've got myself in a situation where they're requesting a different page. Right, let's try it. Written a bunch of code, should run it. Here I am on KV is awesome. Oh, in that case, it's neither of those, so let's test that last. Let's go ahead and just test the home page. Boom, home page. Nice. And then if I go to / about page, nice. It's able to handle that request using an if statement. All within this one callback. Starting to get messy, but at least we're able to get a solution down, right? The problem is what happens if we go to another page, like, right? It's going to just keep spinning. Why is it just spinning? Because I didn't handle any other route. So I haven't sent a response.end, right? And it doesn't know what to do at this point. It's stuck. Node will not, or HTTP library will not just assume that you're done and you sent something back because everything is asynchronous. So it's waiting for that response to end. And since we never triggered it in either of these situations, it didn't trigger these two if statements. It's just sitting there, spinning its tires, right? So let's go ahead and restart. But before restarting, let's put an else. If you request anything else, that should be a 400 or 404, sorry, not found, right? And one of the ways to do that, just to show you a different way, I think is status code equals 404 instead of write head. And then you can just end with not found. Let's restart. And home should still work, but KV is awesome. Not so true. Damn it. So we got back that 404. Oh, sorry, it's over here. Awesome KV is. It's like Yoda. Awesome KV is. So it's 11:05. We'll take a break, 10 minutes. We'll rejoin at 11:15, and we'll look at Express and also some of the problems that this causes and how Express helps us solve those problems. Cool? Let's see if the water's running.
Oh, yeah.
Yeah, is it okay if I check the water first? Yeah, thanks.
know that it's going to do that and then work with the other one?
Yeah, that's a good question. So the listen comes at the end.
Yes, but it doesn't matter because at the end it's asynchronous, so at some point it's going to work. But
Yeah.
the question is, this is most important for working the other one, so I need that first, but I'm not like saying, okay, I need this first and then I can do the other.
Yeah, this is starting the HTTP server, right? This is getting it going so it can start accepting connections.
Yeah.
You can actually move this up, but then it's actually accepting connections, and then it's running the code to decide what to do with the connections. So there's going to be a little bit of time where it actually doesn't know how to handle the connections. But I want it to kind of fully be prepared before it goes out into the world and is able to accept every single request. Otherwise, in that moment that it's turned on, if somebody connects right away and this code hasn't run yet, the get, then it won't know what to do with the requests, in theory. Now, it's fast enough that it should be like a few, it shouldn't matter. But if there was a lot of these and there was some delay between these, then it wouldn't be fully primed yet to know how to deal with things. So normally you keep the listen at the very end, so you know that you've got it prepped, and then you're ready to listen to the connection. Does that help you understand that? Yeah.
Then, so if I do a request, I like the client do a request, but I'm not listening yet, it's going to feel like being in a stack or something like that till I do the connection, and then it's going to.
In a queue, yeah. Connections will be in a queue until it. Well, it may not be in a queue. It may just be like I don't have a route to handle that, right? So it'll just do a 404. Yeah, it'll probably just do a 404 if it doesn't have a route. For whatever reason, if you decide to add a route much later, it'll be 404 until that route is available. Like if I put that in a set timeout, then it won't be accepting. It won't be able to handle it until, and let's say I set timeout for 2 minutes. I've never done this, but I assume that for 2 minutes it'll just do 404s until we add a new route. And actually, I'm going to use this opportunity, because it's something I usually do in this lecture anyway, to kind of just make sure that we understand what's happening here. Where's the red marker? Damn it. I'm going to draw the way that what Express is doing behind the scenes. I'm going to clear this out. So what we're doing is we're calling get twice, and we're drawing we're basically adding like rules to this table. So you can think of it like a spreadsheet or a table where there is like the verb, or as the method, or it's called as the method. And then there's the path. And then what's the final thing? How to handle it, right? So then there's the callback, which is like your function. So yeah, we're adding a get for homepage, and we're giving it a homepage handler function, which takes care of the homepage stuff. We added another one. We added two. We added one for about. So when a request comes in, it uses this lookup table to figure out, okay, this was a get, and it was a /about. So it's not going to be this one. It checks this one first. It goes, nope, not that one. That's not the one. That's the one. And then it knows how to handle that request. Okay? It doesn't execute both of these functions, which means that when that request comes in, it doesn't hit the home page for about, it will hit the about page. These functions cannot be assumed to run both of them for a given request. Only one of them will run for a given request. Just like in our previous example, we had an else if, and only that else if executed for the about page. Okay? So you cannot define a variable here and expect it to be available here. Because for a given request, only one of them is served. Only one of them is called. Now, if I had a variable up here, is that going to be available in here? Absolutely. I can even use template strings to easily concatenated into the response string, right? And just to prove that point, right? That's fine because it's outer scope, inner scope, right? That's just how JavaScript works. It's actually using closures behind the scenes, but we're not going to worry about that. Should I move on to the file stuff that I was about to talk about? Yeah? So we don't want to be just sending back large pieces of HTML like in line in the JavaScript. What we can do is we can install another module called EJS. And EJS is an NPM module, which is embedded JavaScript templates. Now, the documentation for it, the README file, isn't the most useful because it just assumes you kind of know what this means, embedded JavaScript templates. So not the best for like a new learner. But essentially allows us to put HTML into a file, but also put dynamic content, like if statements. So it's kind of like our template string where we can concatenate information. For now, we'll just use it just to get it working without any dynamic data. Okay, so we'll just, instead of saying response.send, we'll say response.render, and we'll say, please render the index.ejs file. Okay? And it won't know what the hell's going on. I'm intentionally causing an error here, I believe. But let's see that error. I like seeing the errors and then fixing them, right? Hopefully you do too by now. So let's go ahead and refresh here. This is the home page, I believe, that we said is going to have the response.render. So here it complains, expresses like, listen, you want to render, but you haven't given me an engine that I can use because there's many different options. EJS is just one of them. So it doesn't know which type of file to render, where to look for that file. There's no engine that's plugged in. Express is very modular. It's not like Rails, which you'll learn later in the program, which is very much like, here's everything. You can still customize it, but I'll give you everything that you need. Express is very much like, here's just a nice little wrapper around HTTP. That'll help you do HTTP well. But then if you want to use EJS, you're going to have to bring that in, right? And that's fair. I think some people prefer that. It's more plug and play, if you will. So, but we're going to have to plug it in. So we're going to have to install EJS, which I think we did. And then we're going to have to enable EJS as the view engine. And that's what we're going to do here. We're going to use Express documentation tells us this is how we tell it to use EJS as the view engine. Cool. Now, it should be able to understand at least that it should be requiring EJS magically behind the scenes, and then using EJS code, as shown here, to load the template. It's going to do this kind of stuff in the back, okay, for us. So we don't have to use EJS directly. Express will use EJS for us.
So we don't have to require it?
We don't have to require it, and we don't have to use the EJS library directly. But we are going to, of course, have an EJS file to be able to have the HTML in it. I haven't created that file yet, though, which means that I'm going to get another error. The error is going to be that the file doesn't exist. It's going to look for index.ejs. Failed to look up view index in views directory. So that already gives me a hint. The directory it's going to look in is /views. By default, you can change this directory, but that means I need a views directory. I'm going to create a views directory. And then in there, in the views directory, I'm going to create a new file called index.ejs, if I was to type it correctly. Okay? And VS Code is nice enough that it already knows that that's a HTML-based syntax highlighting. So it knows to treat that like an HTML file. Now, magically, it's doing a fs read file and all the stuff that EJS library does to go ahead and render this or turn this into a string. Ultimately, Express needs to send back data. We know that HTML is being sent back, which is a string, it's text, hypertext, and HTTP sends back that text. So ultimately, it's all string, right? But instead of putting that string into my JavaScript file, I've put that string into a text file. Make sense? String is in the text file, right? So now, as Andrew was saying, it's nice that we don't have that giant thing that I showed you for Hacker News, right? That giant HTML document. It's not in this JavaScript file. It would be huge and hard to read, maintain. It's in a separate file. Each page can be in a separate file. So if I try to go to the About page after restarting the server, you remember, always remember to restart the server. We see that it tries to render About, right? And I would have expected the error because the About file has not been created in the views directory. There's only index.ejs, right? There's only that one file. We're going to create an About. It's empty. Don't even need to restart the, oh, I guess I did kill the server, so I'm going to need to restart it. Hit refresh, and I get no error, but I get back empty body because the About EJS doesn't have HTML. Now, ideally, a well-behaving template should have the entire HTML tag, but Chrome browsers these days are pretty forgiving if you don't have that. But we should still have a fully formed HTML document. Even this is not fully formed yet. I don't even have to refresh. Restart the server. As I refresh, it works because the template gets loaded when it's requested. And I didn't make any changes to the node server. I just made changes to the template. So if you are working on Tiny App, as you will start today, if you're making changes to the template, you don't have to restart the server. Otherwise, you have to restart it. Unless you're using something called NodeMon, which is a handy tool that you will use to run your server so that you don't have to keep restarting it like I do up here. It monitors your node files, and if they're changed, it automatically reloads them behind the scenes. So it's like a nice little thing that helps us with our workflow. So far, any questions? Yeah. Yeah, absolutely. It's a really good question by Andrew, which is, can we make this even more dynamic? Because one of the things that you'll notice, if you look at a website like a blog or a media site is a great example, or even Hacker News, right? When I click on, I want to see the comments for this, it takes me to an item URL, yeah? And then it has this question mark ID equals, right? And so it's always /item, and then there's a question mark ID equals. So if I go to this one, 4 hours ago it was posted. They're already getting lots of karma, or points. Lots of comments as well on this one. And more importantly, the URL is the same, except the ID is different for the particular record in the database. And so how do we support that? Well, what we know about the question mark, so I'm going to answer your question, but I'm also giving more details, is if we go to /item, that's the URL. That's what's defined in the path here in the table. But then anything after a question mark can include multiple key value pairs as much as we want, well, to a certain limit, character limit. This equals that, and this equals that. Those are two parameters. In this case, there's only one, ID equals, that we can access. Let's take a look if that's true. Request, because it's part of the request that's coming in. It's part of the URL, dot params. I believe it's called. Or is it query? I forget. Let's find out. Console log. In fact, let's make that a separate URL. Let's like make it a website that's more dynamic. So maybe instead of about news articles, it's about like, I don't know, mythical creatures. Yeah? Okay. You're gonna have to help me with the creativity on that for. So let's say like it's a creature fetch. So we're trying to get a creature, and there's gonna be an ID that has to be provided. It doesn't have to be a number. It could be like the name of the creature, some kind of a unique way to access that creature. And so we're going to want to build that using a new route /creature. And we'll just for now just send back hey for now, but we're gonna have to like complete this, right? I just want to see what request.params does, and then work towards it. So we're going to /creature, and it just says hey. But what's interesting is that I get back an empty object for request.params, and I think I can't remember exactly, but I think if I do something like, name equals kv, or let's give it a real. What's a mythical creature? KV is not a mythical creature. A wyvern? Is that right? That's what was in Game of Thrones, right? Those are not dragons, those are verns. Wyverns? Wyvern? That didn't work. So I think it's not request.params, it's request.query maybe? Let me just confirm. Refresh. There it is. So request.query gives me all of these as a nice key value pair. Now, if I was just using the HTTP library directly, I would have to like just get the string, and then I would have to like split the string on ampersand, and then split it again in a for loop. But it's doing that for me and turning it into a nice object. So if I did name equals wyvern and some additional information, like give me page 1 of that. I've got two parameters coming in, and I could use that in my callback function. But another cool thing I can do, as you were saying, is I can actually make this more dynamic. I can say, actually, the name is so required. Like without the name, I can't give you details about a creature. So the name should just be part of the URL or part of the path, right? But instead of defining a new route for each type of creature in a loop, I'm just going to define a more dynamic route, which is /creature /:name. And this colon means something special, means that it's like dynamic. Okay. And now I can access that with request.params. These are the slightly different object that gives us back that detail. So now /creature is not even a thing. You have to say creature. Whoops, sorry. You have to say creature / some kind of a name. It could be anything, any kind of string. Now that will get subbed in for the name key in our object. So now it's accepting that, and we can see the query is empty, but the params includes name wyvern. Okay, so basically what we've said is we are now supporting, not only supporting, we are requiring name to be present as part of this URL to be valid. Otherwise, it will not match. If I just do /creature in my request, it will not match. But the name can be any string, right? It could be a number. Creature 1. That's valid. It's a valid string. So it goes 1. Now it's up to our web application logic, like as developers, to say, let's go ahead and look up that in some kind of an object or some kind of a database and send the details for that creature, right? So maybe I would have some sort of a, because we're not doing databases just yet, your database is really just an object in memory. even for tiny app. So what it will look like is something like this. You can call it database, but we'll just call it creatures. And then it could be an object, or it could be an array. We'll use an object, and we'll say it'll have a key, which will be unique, right? Because in an object, the keys are always unique. And with it will come some details, like how much damage it does. This thing's pretty beastie, right? And whether it's flying or not. Whatever we want, right? I'm kind of just making shit up here. But the idea is that I'm able to have a collection of data and then now have a route, as you were talking about, Andrew, that can support fetching all of these creatures. So I'm going to just define 2. Give me another mythical creature. Spooky ghost. Like this? Because it's an object, so this is kind of like that intro to object stuff that we did. It could be like this, at which point, yes. But generally speaking, because we're using them as like IDs, you probably wouldn't. And you definitely can't if you don't have the double quote there, right? Because then it just invalidates syntax. So we're going to go with the kind of camel-cased approach that we're used to in JavaScript. Spooky ghosts don't do much damage. They're actually kind of friendly, as it turns out. They kind of add health. They're also flying. And so now we can access Spooky Ghost. Well, how do we do that? The URL will include the name Spooky Ghost, at which point we should probably add some logic to go ahead and look up that creature, right? So const creature, we're just creating a temporary variable. Every time there's a request, we'll create a new variable called creature, and we'll set it to be the creatures that are found, the creature that is found from creatures. So creatures, we're going to do an object lookup, square brackets, if you recall, just like with arrays. I'm going to pass in the key. The key will be passed in as a string from request.params.name. That's what we decided to call that particular parameter. Are you guys with me so far? Now, it's possible that they gave an invalid name like 1 or 2, and we don't have that. So we're going to need an if statement to say if creature is found. Sweet, we'll just send back for now the entire creature object. I know it's not ideal, but we're working incrementally here. Otherwise, response will be, I think it's like dot status, slightly different syntax, like a 404. I forget exactly the syntax. I think it's dot status. And then we want to send something like that. Okay, might be not exactly what I expect, but let's see. Learn through errors. So we're going to do wavern, and we get back that object. Now this is not HTML anymore, but again, this is a good incremental step towards what I want. Or if I say spooky ghost, again, that string is valid, and we'll get back the spooky ghost that does no damage. In fact, does reverse the opposite of damage. But if I were to specify some other string, it comes back with a not found, and it seems to work actually, so it looks like I nailed it. And it comes back with the 404. Right? Slightly different syntax for sending a 404 back, but we're not here to learn syntax. We're here to learn approach and how to work with things, right? So don't get too caught up in, oh, why is it status here? Why was it status code in the other library? Doesn't matter. Arbitrary decision, right? Are you guys with me in terms of what I just did for dynamically supporting many different pieces of data and yet having one app.get without having to loop through all the creatures? I was actually able to just say there's a dynamic name that can come through, and then I have to decide whether that name is valid or not and send back data or not. Now, truth is, I'm not going to send back an object. What am I going to send back? Maybe I'll send back HTML, but I don't want to create the HTML in here. I'm going to do response.render and go ahead and render the creature details page, right? And so I'm going to have to, of course, that's not going to work anymore. It's because that file doesn't exist, so we're going to go ahead and create that file.
Could we make it load an image?
Yeah, we can try that. So creature details is there. And here we can have a h1 that ideally mentions the creature's, like maybe it has a name or something, you know, like it can say, hey, this is a Wavern, this is the detail page for Wavern. So we can say something like details for name. Now this is going to result in another error, right? Because this local variable does not exist. So this is what I want to show you again, error-based. First off, what's the error? Let's try it. So we'll be able to find creature details, but once I start the server, it will complain about that line saying, I don't know what name is. Let's go ahead and refresh. We see it here. It's good to see what the error looks like. So go ahead and read that and take a sip of my coffee in the meantime. Right? There's a reference error just like there is in JavaScript. If you just try to open up JavaScript and access a variable called name, right? It's not going to like you very much. Reference error, name is not defined. Reference error, name is not defined. Line 1 on the EJS file. Here's the line. Right? Fairly quite friendly. And we're going to need to pass in this local variable. So how we're going to do that is when we render to the EJS template engine, we'll say, oh, by the way, here's all the data that you need to be able to render this template. This template needs some dynamic data. One of the keys is called name. You'll need some data for name. And so we can just do that as an object and say, by the way, the name is, I don't know, KV, right? And now it's going to allow a local variable called name in the template. And it won't error out anymore. Of course, once I restart my server. So this is allowing us to do that string interpolation using template strings, but instead of it being EJS, ES6 template strings, it's EJS, right? Which looks a little bit different. It uses these special tags to inject additional data into static data. So this is static. This is dynamic. And then back to static. Do you see that? And then we want to include something like maybe a strong to say, you know, what's the damage? And then we wanted to be able to say something like damage. Or maybe there'll be a creature object that maybe we'll just pass in the whole creature object. Because it has dot damage and it has dot flying. So we'll just pass in the entire creature, at which point we will have to say creature dot damage, and flying will be creature dot flying, right? And sorry, the strong should end here, because that's the label. Something like that. Now, right now, this is going to fail, because creature is not defined. So again, please work incrementally and expect these errors to happen so that you know what's going on. You're more in control of those errors. I expect creature to not be defined. So it's going to go, again, same thing as name. I don't know what creature is. So we're going to have to pass that in. How do I pass that in? Same thing, right here. When I render, the second argument to render is all of the data that that template needs. I'm just going to put it on separate lines so it's easier to read. Right? And I'm going to pass in both name and creature. Those are both local variables that it needs. And creature is going to need to be an object, but we already have access to that object, don't we? Because we fetched it from our collection of objects. Right here. This is an object of objects, right? So this object here is already available to us, and it's assigned to this creature variable. So we'll just say, oh yeah, it's creature. So it kind of reads weird because it says creature, creature. But this is the name of the local variable that it'll have access to in the EJS template. And this is the data that we're passing in, which is this local variable here pointing to the object that we fetched. Okay? I could have called this variable creature details, and if that helps clear things up. Right? But to the EJS template, that thing is going to be called a creature because of the key. So now it's able to access that information, and it's going to be able to render the details about that particular feature. Now, the name isn't KV, is it? So instead of hard coding that to KV, I'm going to have to say it's the name. Where does the name come from? I guess it's not in the object. It's in the request params. So I can just pass that through, right? It's 12:02, but I started a little bit late. So is it okay if I show you one more thing? Yeah. Actually, two more things. One is that this is great that it's a detail page, but what about if there was /creatures that listed all the creatures? So we're going to have a /creatures, it's plural, and that's going to be get as well, and it's going to support listing all the creatures. Well, very similar thing. We already have all the tools that we need to be able to render that page. What we're going to do is we don't even need a dynamic thing. Like it's not going to be name or anything because this is all the creatures in the database. Just list them out in a bulleted list or something like that. So here I'm just going to go ahead and response.render creatures list, right? I'm going to have to create. I'm not going to do error-driven here because we know that's going to result in an error. Quickly, I'm going to create creatures list.ejs. And now I expect to see a empty kind of page come back when I go to /creatures. It's going to be plural creatures, and it's an empty page. Now on that page, I need to loop through every single creature and create a li, let's say, for a list item in HTML or paragraph or whatever. So let's go ahead and do that. Creatures list. Here's my HTML. It's going to say all creatures, if you can spell that. And then here we're going to need to loop, right? So we're going to need to loop through all the creatures. And what you saw me doing earlier was using this tag with the equal sign. But when we're looping or using if statements, we're not actually injecting HTML dynamically just yet. We're just doing a kind of a control flow. So we're not going to use the equal because an if statement doesn't actually evaluate to anything. It decides which part to go into. Or same thing with a for loop. So we're going to actually not use equals and just say for const creature. It's for arrays, right? But we're doing objects. But we can turn that object into an array. So for const creature of object.keys creatures. If you recall this from week 1, this is one way of looping. And notice that it's such weird tags here to both start and stop the loop. If I'm writing JavaScript, I have to start it with this. But in here, I'm going to have my, let's say, div. And the div will have, let's say, a strong, which for now I'll just hard code. And then maybe it'll have a paragraph. And in the paragraph will be, maybe not a paragraph. Maybe there'll be like a EM. And in it, it will just say, whether it's damage and then flying, right? Something like this. So in order to do this, this is going to fail because I'm not passing in any data. I'm not passing in creatures as a collection. Agreed? Because when I called this, you'll notice I didn't pass in any details into the render. Here, I did. I passed in an object with the details of the creature. Here, I passed in nothing. So there is no creature's local variable. And much like before, it will complain that that local variable does not exist. On line 5, we see right here, creatures is not defined. In order to define creatures, I need to go in here and say, you have an object. In that object, I'm going to pass in the name of the variable, creatures, as the key. And the data will be that whole object. How do I access that object? It's right here. It's called creatures, same name. So we're going to say creatures. Excuse me. And so we have, this is essentially, we should be seeing this as the object in our eyes, but we're referencing it via the variable name. You guys with me so far? So now we're looping through creatures, and I know there's 2 in there, so I expect to see maybe KV twice, because it's hard-coded right now. Oh, I need to restart the server. This is, by the way, a big gotcha where you make some changes and you're like, it's not working, I must be going down the wrong path, even though you were going down the right path. You didn't restart the server. I'm sure it's happened to you in weeks 1 or 2. Has it happened yet? So same idea in the node server, right? It can happen there as well, unless you're using NodeMon. But always just double check. All right, so we see KV twice. That's because there's 2 entities or 2 keys inside of creatures, and we're going to need to make this dynamic. So we're going to need to do the name, which is going to be using equals now because we're injecting it into this strong tag. And it's going to be, by the way, this is not creature. It's actually creature name because it's just a key. So the creature name. There it is. And then the damage will be creature name dot damage. And then flying will be creature name to access that particular object dot flying. Both are flying, so that doesn't really help. Let's go ahead and add 1 more in there. 1 last creature, folks. 1 that's not flying. Unicorns fly, though. Let's make this one unicorn without wings. Unicorns do fly, right? Yeah. I thought I saw one the other day. And this unicorn is just a freaking badass. So it's really actually a badass unicorn without wings. Right, we see that working. So this is going to be very similar to what you'll be doing in your Tiny app starting today at some point, hopefully if you've done the weekend stuff, in order to show data that the user is able to create or even just see that's in the database. So that's 12:09. I've kind of gone a little bit over time, but I started a little bit late. Any questions before we adjourn? Yep. Yes, good question. Render is like your write, dot write, and then it writes the actual EJS results, and then a dot send. Sorry, a dot end, right? Yep.
Could you explain to me how you were pulling the information from the Express server onto the feature list again?
Yeah, great. Anthony's asking about kind of how we're wiring together the HTTP responses and stuff, along with this data up here.
Yeah.
So what?
Like more like the data onto the other files. Like I get like the response.
Oh, okay.
Part, but it's just mostly just how are you pulling the data from like the objects into like the feature list, for example.
Into the EJS templates itself. Yeah. So the EJS templates, as their second parameter, when you call .render, Express will take in all the data that you want to pass into the EJS template. If we look at the EJS documentation, we see that when we call EJS.render, which Express does for us behind the scenes, we're just doing response.render. But really, it goes to EJS render. And it's like, here's the actual file contents, which it loads from the file using fs read file, right? So it passes the file contents here. And then the next is data. And then if we look in their documentation, what the hell is data? It shows us an example, right? And because there's users here, there's a variable called users available, right? And therefore, you're able to do a users.for each, for example, right? Now you can do other cool things with EJS, which I haven't covered yet. So it's, this is an introduction, but you can actually have like other EJS files so that you're kind of separating this large file into even smaller files, which is really nice. But we'll let you figure that out through the class, like through the lab portion. But yeah, hopefully that answers your question, Anthony, which is like, it's part of the EJS's definition, and therefore Express is saying, please pass that in as well. And it's an object because key values, right? And the key is the name or the variable name. So these are local variables available now to the template. So this template, I know without looking at this template, I know this template has 2 local variables it can use, name and creature. Whereas this one here, creatures list, only has 1 local variable called creatures. And the right side is the data that's passed in for that variable. And then in the EJS, I have creatures.forEach or for of creatures. Now, as a dev, I have to follow along and be like, what is this thing? And then go find it up above here and realize it's not an array, it's an object, therefore it's going to be, we're going to have to loop properly and all of that stuff. Yep. Well, if you have 2 files, in week 1 you worked on low tide, and you had 2 different files, one was requiring the other. Was a local variable in one file available in the other? Not unless it was actually passed through, right? So similarly, yes, our EJS is being used here, but it's a separate file, separate module, if you will, and therefore doesn't have access to the data that we have here. Right? So we have to explicitly pass the creature's data through. Good question, though. Yep. It's a good question. I showed you params. Where was it? Right here, which came in using the question mark approach. And then I showed you creature's name. Sorry, the question mark stuff was the query, request.query, and the params was like built into the route, therefore required for that route to actually be a valid request that comes in, right? So one is just part of the path. Therefore, it's like, if you look at certain, as an example, because I showed you an example where it's passed in as a query string after the question mark. But if you look at something like New York Times, and we go into an article, you'll notice there's no question mark. Well, I mean, yeah, there is some question mark stuff, but the main details of how it looks up which article it is in the URL itself. In fact, it's /year /month/date, I assume, /country /some title.html. So it's actually taking that URL and instead of just one argument, maybe it's got like a whole bunch, right? And their pattern is, listen, this is required, and it reads nicer instead of question mark, right? ID equals whatever, like it's more SEO friendly and all that stuff. So we'll do it this way, they decided. So it's a decision on the web designer or web developer, architect, to say this is how we want the routes to look. And there may be business reasons for doing it one way versus the other. Hacker News doesn't care about SEO, right? In fact, it's supposed to be like a closed community. So they don't really care about SEO rankings and just trying to make that a more readable page. But that's not the only reason. They just, for whatever reason, they think, well, ID is required, but we're going to make that like query string parameters. I would have gone with the item/ID. They decided to go with item question mark ID equals ID. But usually when it's a required field, I would argue that it should be in the parameter, in the URL itself as a parameter, versus if it's like other information, just more context. More context, for example, in the New York Times is, where did they come from? Did they click something, or did they come from an email? Where did they come from? For tracking reasons. And which part of the thing did they click? Oh, they clicked on the top part of the website and from the homepage. Right? They're just doing tracking here with these other parameters. so that in their logs they can see where people are coming from for that article. So it's more optional information that's not required. I could get rid of all of this, and the article will still work. Right? The important information is in the URL itself, which is very similar to what we did with the creature's name. Right? So that's more of the common pattern, but Hacker News does it the old school or the wrong way, essentially. Although it's not really wrong, it's just not as nice. Right? It's a good question. I had in my agenda, let's go back to my agenda. I had in my agenda really as a stretch. Sometimes in lecture, if I go faster on the first stuff, I end up covering middleware. It's not something that's going to trip you up completely, or you'll be able to look up enough to be able to get through it. So hopefully in a later lecture this week, we'll be able to cover middleware. It's a little bit of an advanced topic. What I'll give you as a foreshadowing or as a teaser is that middleware is actually underlyingly what we already started using, and it's how Express works. The functions that we gave it is actually middleware. If you're curious about that, you can read up a little bit about Express and middleware. You don't really need to understand that in order to start building your app. So it can come that knowledge can come a little bit later. Is that okay? All right. I will leave it there, and I'll send notes out. Cheers, everybody. Hey. Okay. Perfect. I just finished. I'll just come. Hello? Deja vu. Thanks for bringing the coffee again. Yeah, Carl's last one, first one we new program, went to like hours long. Cut it down. But I can. Yeah. Hey guys, I just want to make sure 12:30 you're going to be okay because we need the room at that time, or we could figure out alternatives. Okay, you're good. Okay, cool.